Apart from those drawing functions, the Android canvas can also perform affine transformation. Affine transformation is a linear transformation on the mapping of points and lines without modifying its vertex coordinates. For example, these functions allow us to move or rotate a 2D object. Let's look at 4 ways we can use this. We can perform translation to move an object, rotate it, scale it, or shade it. Let's look at each of these in more detail. We can translate an object to another location by adding or subtracting each vertex coordinate with the x, y displacements, in this case A and B. To rotate an object, we can use this equation to rotate the coordinates of their vertices. Theta is a rotation angle, so we can use the cosine and sine theta to rotate the object. To change an object size, we can multiply their vertices with the scaling factor, in this case C and D. We can shear the object by incrementing the x and y coordinates of the vertices with the origins of y, x times the shear factor E and F. Instead of 2 equations for each translation, we can represent the coordinates and transformations with vectors and matrices. Let's have a look at this for each transformation. For example, translation basically is a summation of 2 vectors. Rotation can be represented as a matrix multiplied by the 2D vector. Scaling can be represented as a matrix times a vector, and the same with shear. It's nice to formulate affine transformation into vectors and matrices, but different equations and functions have to be used for the different transformations. It's better to have just one equation than for one function which can do all these different types of transformations. How do you think we could do this? The answer is use homogeneous coordinates. To convert a vector to homogeneous coordinates, we simply increase the dimension of a 2D vector to 3 and assign the value 1 to the new dimension. By using homogeneous coordinates, we can perform translation, rotation, scaling, and shear by simply multiplying the homogeneous coordinates with a 3x3 transformation matrix. So let's try and modify our program to see how we can transform the polygon object. Before adding the transformation functions, let's create an array of points representing the vertex coordinates. Then we add the new function to update the path object. Basically, we first reset the path and then assign the path with the values in our point array. We can then write the affine transformation function, which will take an array of vertices and their transformation matrix as the input. In the function for each vertex, we perform the matrix calculation. As we are using a point array for our vertices to perform the transformation, we assume that each vertex is a homogeneous coordinate if the value in the 3rd dimension is equal to 1. Then we can define the translation function by creating a transformation matrix for translation and then call the affine transformation function. To see how it works, we can add the translate and update path functions in our onDraw function before we draw the black border of our polygon. In this case, we want the back polygon to translate by 20 pixels to the right and 40 pixels downward. Try completing this in your app and then return to see the output on my screen. When you run the app, you can then see that a new black polygon is drawn and is slightly displaced from our previous designed polygon.